Okay, we're going to go ahead and take a look at our most basic stoichiometry problem, and that is a mole to mole problem. And so with any stoichiometry problem, notice that you're always given some sort of balanced chemical equation, where you're going to have the balanced chemical equation. And in this first one, I've just given it to you just to keep it simple. Think back to those steps, guys. If 9.12 moles of ammonia in H3 reacts with nitrogen monoxide, how many moles of water will form? So once you've read the problem, step back and look what information is given to me. And again, what information is given, think numerically. What values do they give us? So hopefully you're seeing that right there is what is given. And in our rules, I asked you to start by writing down what information was given. And this is another thing that I noticed on your quiz. You need to include the units and what compound those units are associated with. And you're going to see why as we progress here. So we've written down the given. Our second step is what units are we trying to get to? What's the end product that we're looking for? And if we look at the question, it says how many moles of water. So right there, that's telling me what I'm trying to get to is moles of H2O. Once you've identified that it's a mole-to-mole problem, let's go ahead and draw our T-chart. Again, if you look back at those steps, you've got to get rid of moles of NH3 and somehow get over to moles of H2O. The only way to get rid of these units, guys, is to drop them down. So here we drop down moles of NH3. Well, now I see mole over mole. And if you go back to the tutorials from Tuesday, I told you anytime you see mole over mole, that's a molar ratio. And anytime we're looking for the mole ratio, you've got to look up here at the coefficients. So find NH3 in the original problem and notice that it has a coefficient of 4. And what that's saying is that 4 moles of NH3 reacts to produce 6 moles of water. Okay? So think about what we just wrote. Coefficients, mole over mole, look up here to the coefficients. Moles of NH3 is gone, and look, we're exactly where we want to be. So at this point, we would put 9.12 in our calculator times 6 divided by 4. And I want you to see, you can't see how I really put it in my calculator, but if you put it straight in as 9.12 times 6 divided by 4, you're going to get the same answer, which is 13.68 moles of H2O. Pay attention to how many sig figs we need. If you look at this original given, there's 3, which means we want 3 significant figures. So 13.7 moles of H2O would be our final answer. Once you get good with the stoichiometry and you practice a little bit more, you're going to notice that anytime you have a mole-to-mole problem, it is always one step. But I don't like for students to memorize that because if you understand the process, there's no need to memorize that it's a one-step problem.